Hello guys, welcome back to the channel, and this is day 4 of daily Leetcode challenge of June month. So today's question is pretty easy. This is a number of provinces. So let me explain you the problem statement first. So there are n cities and some of them are connected while some of them are not. If city A is connected directly with city B and city B is connected directly with city C, then city A is connected indirectly with city C. Province is a group of directly or indirectly connected cities and no other cities outside of the group. So what this mean is actually like in this case, like in example 1 we are seeing 1 is connected with 2. So this is like one provenance, like this is a one group, you can treat like this is one group. And 3 like 3 is not connected with any other node, so this is like one provenance. So one provenance is this and one is this. So this is like two groups. We have to tell like how many groups are there. Okay, like in the next example we are seeing these three nodes are there, but they are not connected with not any other node. So these three are separate groups. So like here this is three. Suppose in this case like these all three were connected with each other, so in this case the group will be one. I hope the question is pretty clear to you. This is like easy one. So what we have to do is yeah. So what we have to do in this question is we have to just tell number of components in a graph. So how you will approach to this problem is you have nodes and you have vertex and you have edge in the graph. So this is a graph problem, and you have to like basically you have to do it just a simple traversal. Whatever traversal you may prefer, BFS or rather DFS, you just have to start traversing from node 0 to node n. Since you have n cities, so you will loop from 0 to n. Okay, this is n, sorry for my bad handwriting. So this is like 0 to n, you have to traverse. And you will be for traversing we will be using one visited array from 0 to n. So this visited array will tell like which node is visited and which is not. So we will initialize this, like here we have three cities, so we will make like of size 3. So -1 -1 -1. So -1 is indicating this node or this city has not traveled yet. So we will check like from 0 to n, like we will check like zeroth node for example. So like you will be saying this is you are taking from 0 and this is from 1. So since we are giving number of groups, so it doesn't matter we start from 0 or 1. So from we will check from 0 if is this city visited. If this is not visited, like we will write like this visited of I. If this is equal to -1, that means this city is not visited, so we will visit that city. By visit that city I mean we will traverse that node. So we can use DFS or BFS, whatever you like, for that particular node, that ith node, and we will visit that component. So we will start the traversal from here and we will reach to here, and we will mark both of these cities as visited, since these were -1 previously. So this will be our 1 now. This will be 1 because this is 0, this is 1, and this is 2. Like here it is 1 2 3, but we are taking 0 1 2. So like 0 and 1 is visited now, because we have traversed from this 1. And now we will be checking, is 2 visited? Yes, 2 is also visited, we have visited. Then it will check, is 3 visited? We will say no, 3 is not visited. Then we will go and traverse 3. So we have seen we we did two traversals. So we have to just count number of traversal, either DFS or BFS. So like we have to just return number of traversals. Okay, so let me show you the code. This is BFS. I have also tried with DFS. I will show you both the codes. So you have to just initialize one answer to store number of traversals. Then n is the size of this matrix. And in this matrix, like they are giving like this is 1. So what 1 mean? This is 0 to 0, like you can say 1 to 1 or 0 to 0. And like this is 1, so what this mean is 0 to 1, like uh, let me explain you, like 0 1 2, you have three nodes. Okay, then if it is 1, then this means 0 to 0 it is 1, then this is 0 1. So like this is the connection, this is the edge between two nodes from 0 to 1. Then this is 0, this third one, that means 0 to 0 to 2 there is no edge. Okay, so this is graph. So with this we can easily tell the adjacency nodes of any node. So this is like similar to a adjacency list. Okay guys, so in adjacency list we have like nodes store for every node. So here we can also like find like that. So we will be traversing on every node. We will check if this node is not visited yet. If this is not visited, go and visit with this bfs or dfs, you may like go visit that node and increment the number of traversal. So this bfs will go here. So we are using the queue here as usual we do for bfs. Then we are pushing that particular node, in this example 1. And now we have pushed this node, okay, to our queue. So this is our queue and we have pushed one in this queue. And then we will then we are extracting the v is what this node. So we have extracted this. Okay, we have extracted this. Then we are checking who are the a neighbor node of 1. So we are checking neighbor node of 1 is 2. So I will be pushing 2 in the queue, and I have already popped this current node, that was 1. So now I have only 2 in the queue. And in the while in the visited array, like at the place of 1, where it was -1, this is 1 now. And at the 2, like we have stored the 2. So like when we are storing the 2, at that same time we are also marking it as 1. So 2 is also marked as 1. So like from the next time we will check is 2 visited, it will say yes, it is visited. Then we will again we will extract 2 from the queue. And we will see like who are the neighbors of 2. So like 2's neighbor is 1, but that is visited. Like here we are checking is that adjacency node is -1, that means not visited. We will say no, 1 is already visited. So what we'll do, this will like this bfs will finish with this. When this will also popped out, so this will say like queue is empty now, so this bfs will end it. This is our like first bfs traversal. Then we will check like in this for loop, this will check like is 1 visited, then is 2 visited, 2 is also visited. Then it will check is 3 visited. So we'll say no, 3 is not visited. Then another bfs call will visit 3. And this is how it will work. And let me show you the dfs code also once. You can prefer anyone. So like dfs also similar, like same I have done. If the node is not visited, like traverse any like loop on every node. If the particular node is not visited, go visit that node with dfs. So just like put like mark it as visited. And then you can just go to the adjacent nodes and check if that if it is an adjacent node. And also if this is not visited, go visit that node. So this is how you will be doing dfs traversal. And I will be pasting these both the codes bfs and dfs to the comment section. You can see. And we are solving lead code challenges, we are trying to solve the daily lead code challenge, and I am trying to be consistent with that. So you can if you have liked the approach, you can like this video and consider subscribing it. We will be coming with a more solutions and contest solutions also. Thank you.